Okay, I'm going to walk through problem 37 to show you how to use your TI-83 calculator to graph data in order to determine if it creates a straight line. Because if you graph y versus x and it makes a straight line, then you know that you can figure out which integrated rate law, well, you can figure out the order of the reaction based on what you use as y. And this problem asks us to determine the rate law, the integrated rate law, and the value of the rate constant, and then to calculate the concentration of hydrogen peroxide. The first thing you need to do is calculate or figure out what order the reaction is. And in order to do that, you're going to plot some data. Okay, the question said that hydrogen peroxide decomposes, so the reaction is at the top, and it gave you this data. Now, if you plot as a line, if you plot this concentration data as y and this time data as x, and it gives you a straight line, that would mean this reaction is a zero-order reaction. Zero-order reactions are unusual because it means that the rate does not depend on concentration. At some point, the rate has to depend on concentration, because if you have no concentration, you can have no reaction. So this is probably not zero order. So I'm going to draw a line through this. Okay. The first thing we will plot, there's a glare here, is the log of the concentration versus time. Because this is actually a linear equation. I have rewritten it here. First of all, I've labeled it on my equation sheet as first order, because it's the first order integrated rate law. Then I've rewritten it as y equals mx plus b. Our y points will be the log of the concentration. Our x points will be t. If it creates a straight line, our slope will be minus k, and our y-intercept will be the log of the initial concentration. That's an a to the 0. So to see if that makes a straight line, I need to calculate the log of the concentration of hydrogen peroxide. I use my calculator to do that. I hit natural log. Where's my button? Oh, I turn it on first. And I hit natural log. I'll clear it first. Natural log. Then I will put in the first concentration, which is 1, close parentheses, hit enter. The natural log of 1 is 0. I write 0 down. I'm going to do it now for 0.91. Natural log 0.91, close parentheses, oops. Natural log 0.91, close parentheses, enter. Minus 0.0943. I'm going to maintain 3 significant figures. Well, really I only need 2, but I'll keep 3 for now. Minus 0.943. So don't round too much. Oh, and I wrote it down wrong. It's 0.0943. I'm going to calculate the rest of these and then restart. Okay, I have now calculated the log of this concentration, the natural log. This will be, I'm going to plot this as y, and I'm going to plot this as x to see if y versus x, this particular y, creates a straight line. If not, I'll have to try the second order integrated rate law. But I'm going to do first. I'm going to see if it fits this first. This is experimentation. So I need to plot this as a line, and I'm going to use the calculator to do that, and that's what I want to show you.